So unfortunately, I have lost my daily LeetCode streak. I thought it updated at 7, but it updates at 5, and I was 10 minutes late to getting this done. But it doesn't matter, we're still getting it done. So today's/yesterday's daily LeetCode question of the day is balance a binary search tree, number 1382. So for this problem, we're given root of a binary search tree, and we want to return a balanced binary search tree. So we want to have subtrees, right? So we don't want straight lines, we want subtrees. So this is good because we want subtrees. So my idea for this problem is we can make an array list and turn this subtree into an in-order transversal. So we'll make an array list containing 1, 2, 3, 4, blah, blah, blah. That way we can do a recursive tree building method, and that way we can create subtrees within subtrees. So first things first, let's create our array list. So list integer list is equal to new array list. So we want to build this list. How are we going to build it? We're going to do it in order traversal. We're going to pass it root, and we're going to pass it list. So this is going to be a private void in order. It's going to accept a tree node, and we'll call it temp, and a list type integer called list. So this is also going to be recursive. Recursive basically just means it's going to call to itself multiple times, and the way that we solve how many times it's going to call to itself is if temp is null. So an in order traversal is going to go, say we're starting here at 2, it's going to look at the leftmost node. At the leftmost node, it's going to look for a left node. There's no left node. Then it will add the middle node. Then it will look for a right node. There's no right node. So it'll come back to the middle node and go back to the previous node because it's recursive. And then it'll add this node, go to the right node, look for left, add the middle, look for right, so on and so forth. So we want to break this recursive loop by checking if temp is equal to null, simply return nothing because we're ready to break the loop. Otherwise, we will go to the leftmost node because we want it to be recursive. After we check our left node, we then want to add our middle node. So we could do list.add temp.val, and then we could check our right node in order temp.right. Then we can simply return nothing. So this creates our in order list. Next thing that we want to do is make a recursive tree building method. So we can call to, what we can do is return tree build, call it tree builder. And we're going to pass it 3 things. We're going to pass it our array list. We're going to also pass it the start of that list and the end of that list because it's going to be a recursive. So we can pass it list. The beginning of our list is 0, and the end of our list is going to be list.size. -1 because we don't want to go out of bounds. So let's go ahead and build this method. So private, we want to return a tree node. So tree node, and that's going to be our root. Tree builder, and we're going to have our list type integer called list. We're going to have our start, and int end. So first things first is how do we break a recursive loop? We have to check one thing. If the start is greater than the end for any reason, then we're going to break our loop. So start is greater than end. We want to return. Otherwise, actually we could return null. Otherwise, this is where we start doing our recursive method. We want to find our midpoint. So int mid is going to be equal to our start plus our end minus our start divided by 2. Then we can we can make new node. So tree node left is going to be tree equal to tree builder, and we're going to pass it the same list. However, we're going to, for the left side of the tree, we're going to keep it at 0 for the start, but the end is going to be mid minus 1. Then we're going to do the same thing for the right. So tree node right is going to be equal to tree builder, and we're going to pass it the list. But instead of 0 for the start is going to be mid plus 1, and the ending is going to be list dot size minus 1. So now we have a left subtree and a right subtree. What we want to do for this as well is we're going to create the node that is going to connect the left and the right. So in this case, it's also going to be our root. So this is what we're going to be returning. So we're going to make a tree node, and that's going to be equal to a new tree node, and we're going to pass it the value of mid. So list.get mid, left as its node.left, and right as the node.right. And we can return our node. So if we run this should pass our test cases. Okay, what did we mess up here? Stack Overflow error, cool. So this happened because we used 0 instead of start, and list.size minus 1 instead of end. So we can run this, and this passes all of our test cases, and we submit it. This passes all solutions. Let's go ahead and do this in Python now. So for Python, it's basically going to be the exact same thing. First thing first, we want it to define a list. So first things first is we're going to initialize our list. So we're going to call it list is equal to square brackets. Then we're going to call to a function to add to this list. So we're going to do an in order traversal, and in that traversal we're going to pass root, and we're also going to pass list. One thing we have to remember in Python is we're using self dot. So we're going to define our new in order, which is going to pass back self. It's going to pass root, and it's going to pass list. So in this, if root is equal to none, we're going to return. Otherwise, we are going to pass in order root dot right, left first, because we're doing in order, as well as list. List, we're going to list dot append root dot val, and in order root dot right, comma, list, and return. So that should create our list. Now we want to return our tree creator. So self build tree, and that we're going to pass our list, we're going to pass our start, and we're going to pass our end, so length of list. So let's go ahead and define that function now. So define build tree, it's going to pass self, it's going to pass list, it's going to pass start, it's going to pass end. So we never want start to be greater than end, so what we can simply do is if start is greater than end, return none. Otherwise, what we're going to do is, first off, we need to find our midpoint. So mid is going to be equal to start plus end minus start divided by 2. And we're going to create our left and our right tree. So how do we create a new node? I think what we can do is we can define it. So let's see. Up here, self.val, self.length, self.right. How do we define tree node? So down here, we're going to want to add self dot in front of these. Pretty sure I'm going to add it in front of root as well, if I am correct. Self dot, self dot, self dot. We might even need to add it here, but I'm not going to quite yet. So, how do we initialize a new root? So I was wrong. We do not need to use self dot for the root part. So just delete this. But we do need it for the in order part. On top of this, I spelled build tree. Anyways, to define a new root, what we're going to do is we're going to do temp. We're going to do node as our root. I'm thinking of just doing the left and right nodes, and then we can add them to our root as is. So what we're going to do is we're going to return self dot. We're going to define a new node. So left is going to be equal to tree node, and the tree node is going to consist of left. It's going to consist of self dot build tree list, comma, the start, and the end is going to be mid minus 1. Then we're going to define a new node right, which is going to be our tree node. It's going to return self dot build tree list, and the start for this one is going to be mid plus 1, and the end is going to be end. Then we can define our node, which will be equal to tree node, and that's going to consist of mid. It's also going to consist of left. It's going to consist of right. But not just any mid, this needs to be list of mid. So list dot get, or is it going to be list? So this is going to be list of mid. And then we're going to return our node. We run this. Did not pass our test cases, so last indices must be sliced. So from Python, we don't want to use the same technique we did in Java, so we're going to initialize a node. It's going to be a tree node, and that's going to use list of mid. Then we can do node.left is equal to build tree, and we can pass list start and mid minus 1, and node dot right will equal build tree list and mid plus 1 and end. But we want to use dot self or self dot. Now we can simply return node. Oh, and make sure you use double divider so it doesn't turn to a float. This passes all of our test cases, and this should pass all solutions. Thank you, and follow and subscribe for daily LeetCode problems.